All right, so we are in Algebra 1. Today's date is Tuesday, January 7th, 2020. We're talking about solutions to inequalities today. I'll put the date here as well, 1/7/20. Make sure your name and date are on your notes. Who would like to read the objective with a quiet raised hand? Get that participation card in. Emma, yes.
Determine if a point is the solution to a system of inequalities algebraically and mathematically.
Exactly. So by that, you can kind of look at the back half, example 4 and 5. If you can solve example 4 and 5 right now, you have now hit the objective. This is algebraically, this is graphically. All right, but we need to figure out what those mean. So let's do a little bit of review. So I pronounce this left one as less than. And again, all this is coming from this board up here on the far right. So it's going to be a living textbook. It will stay up there during the test and all that. I have a less than and a greater than. So underneath this, I can say less than. And this one I can say greater than. Okay, what about in the top right and the top left box here and here? What? Yeah.
Less than or equal to would be the same sign as less than, just with a line underneath it saying that it could also be equal to. And the greater than would be the same thing as the greater than symbol with the line.
There it is. Yeah, cool. So make sure that you know which direction those are going. Thank you, Wyatt. So organized. All right, so a greater than is represented with an open point. I call this open, so I can write open next to it if you'd like. Anyone want to try to fill in the types of points in this entire row? Emma is our backup. Wyatt is another backup. I'm looking for cards. Kira, yeah.
I think the greater than or equal to ones, or like the or equal to ones, are all closed circles, and then the less than would be
And then, sorry, the less than is a what?
open circle.
Open, yeah. So we have open, open, and then we call these closed. Like a door, open or closed. You can think of it as a little hobbit door, because hobbit doors, I think, are circles, right?
Yes, they are.
All right. So we now need to draw the comparison between what an open versus a closed point means in terms of a two-dimensional graph. So on these open and closed points, I consider that what would happen if I was graphing on a number line. So write number line off to the side. Number line. If I was graphing an inequality on a number line, these are the symbols that I would use. But if I'm going to graph on a coordinate plane, so I need to come over here, coordinate plane, then I'm going to be talking about this row right here. On a coordinate plane, a closed point is the same thing as a solid line. Anyone want to take a guess as to what an open point is going to look like? I have a good backup. I'm trying to get more cards in. Jade.
Dotted.
Yeah, a dashed or dotted line. And you can fill in the same thing for all of the less than and the greater than or equal to. So this one is going to be some sort of dashed line. This is going to be some sort of solid line. What's important to distinguish now is that whenever I had an open point, I cannot actually have a value there. If I saw some sort of graph that has an open point and then nothing over here, I can't actually say, if I put my finger on that point, that doesn't exist. I'm not allowed to be there. I can be over here, but I can't be there. The same thing, if I have some sort of graph that is shaded in over here, I can be in the shaded in area, but I can't touch that dotted line. If it was a solid line, yes, you can't have a point on the solid line, but because it's a dashed line, any point that is on that dashed line, you cannot, that's not an answer. It's very, very similar. All right, let's move on. So when we had a less than in terms of the number line again, so I'll come down here and say a number line. On a number line, a less than meant go everything to the left. Anything to the left of that point is an answer. I need some quiet raised hands to help me fill in this table. I have some good backups and I want to get some more cards in. Ulysses, do you have your card?
Yeah.
All right, yeah. Go ahead and help us out.
Like, greater than be like to the right,
It is indeed the right. You want to keep going?
and then the less than or equal to be to the left.
Left and
Right.
thank you, yeah. And that should be our review from a number line. Greater than, so if I say x is greater than 7, anything bigger than 7, anything to the right of the 7 on the number line is an answer. But now let's come back to a coordinate plane. What most of us think of as a graph, an x and a y axis, a coordinate plane. Well, now whenever I say greater than or equal to, I'm really talking about anything that is above the line. Above or to the right. I guess you can kind of combine these two. So how can I fill in these other ones? Why is it back up? Esha, yeah.
Well, could it be above for all of the right ones and below for all of the left ones?
Yep, exactly. So above for the right ones, above and below. And it's kind of a misnomer to say below or above. You can even keep using the words left and right and it'll still work. But sometimes you might need to use the word below and above. For example, if I have this, like I'm going to do a sketch off here to the side. If I have a graph that just has a horizontal line, how is it possible to have anything to the right of that line? I can only have things that are above or below. Or what if I had a line that was straight up and down a vertical line? I can't have anything above or below. I need something to the right or to the left. That's why I have to use both of these words. All right, so let's come down here and talk about example 1. I just need to test solutions. All about today is it a solution? So is 2 comma 3, is this point on the graph of this, is that a solution? How are we going to solve this? Anyone want to try? Wow, lots of hands already.
I have like
We'll go with a repeat. Yeah, Emma.
plug in 2 for x and 3 for y.
Yep, so it's going to be exactly. Plug in 2 for x.
Minus 2.
Exactly. Let's plug in, again, the x was the 2, the y was the 3, and plug them in. I need someone else to help me simplify this. What happens when I plug these in? Eamon, yes.
You would multiply 4 by 2, which would be 8, and then you'd multiply 2 by 3, which would be 6. When you subtract these two, you get 2 is greater than or equal to 1.
Is that true?
That is a true statement.
Oh, okay. So we'll come over here and we can write true. And because it's true, we know that it is a solution. So because it's true, you can say, maybe I can move this up here to actually write my full answer. So true, and then therefore it is a solution. Is a solution. And I'm just going to abbreviate SOL. It is a sun, I guess.
So if it's true, it's a solution, and if it's not true,
Then it's not a solution. All right, so let's try another one. I want to see all of us working on example number 2 on our own, and once you finish, please check with your partners or people around you. Your what am I saying? The elbow partners. Forgot the word for elbow for a second. All right, I need my stylus, first of all. I put it back there randomly. I need a quiet raised hand to walk me through this entire problem. Anyone have their card still? Everyone has their card in already? We'll go with Esha.
okay. So you plug in 2y and x, and 7 is y, so it's 3 times 7 minus 4 times negative 3, or negative 4 times negative 3, is less than 33.
Okay.
And then you do 3 times 7, which is 21, plus 12.
Why plus 12 instead of minus 12?
Because if you multiply 2 negatives, it becomes a positive.
Good, all right.
And less than 33. And then you get 33 is less than 33, which is not true.
Okay.
So there is no solution.
Not true. Which implies
not a solution. I can abbreviate here, not a solution. Perfect. How could we have made this true just by changing this symbol? Anyone want to talk about that really quickly? Asha, go again.
Well, if we change that symbol to, well, we could change it to less than or equal to, or could we change it to like unequal to?
Yeah, both those would work. And what?
Or greater than or equal to.
Or greater than or equal to. Yeah, all three of those symbols would work. Perfect. Let's move on to example number 3. You already have it done. I want all of us right now on your own, just graph the point -2, 4. Figure out where it is. Graph -2, 4 on this plane. Make a point, make a little dot. -2, 4. Where does that live? -2, 4. And if you did it correctly, you should have a point on the top left quadrant, which is quadrant 2. It goes 1, 2, 3, 4, starting in the top right and going counterclockwise. So this is -2, 4. And then the question that you ask yourself is that in the shaded region? We all nod our heads yes. Therefore, the answer is yes. Yes. And then for the notes, just so that you guys can remember, because in shaded region. All right. You guys on your own now. Is -4, 1 a solution? Graph -4, 1.
Wait.
I try to be tricky. -4, 1. Okay, well, if you aren't there already, -4, 1, I'll do this one in yellow, is right here. It's on the line. Okay, it's a dashed line. Go back up to your notes. Is that a solution? Wyatt?
No, it is not a solution because it's a dashed line saying that it's either like less than or greater than, so it's not in the shaded area.
Yeah, dashed line. Perfect. Yeah, that boundary line that divides the realm in between darkness and light. That boundary you're not allowed to be on. That belongs to the light, I suppose, not the dark. Okay. All right, so that is example 3. Questions up to this point. Those are the basics. Now we're going to combine everything. All right, so we're talking on the backside, solution to a system of inequalities. It's very similar to a solution of equalities. So a point is a solution to the system of inequalities if it satisfies blank of the inequalities. There's a bunch of words that you could fill in here, a few that are correct. Ulysses?
Is this both?
It is indeed both, or all, or any word that says you need to satisfy all the things that you're talking about. Both inequalities, in the case that you have 2. Because I'm always going to be giving you 2. Although, I think it would be a fun challenge if I gave you guys like 7 and overlay it on the map of the school, make it into a treasure hunt. That could be fun. The solution to that giant system of 7 inequalities is the answer to where the treasure lies. Yeah, Wyatt? Off topic, wait until after. Thank you. Okay, so example number 4. You can write down your question if you are scared that you'll forget it. So, is 2, 1 a solution to this system up here? Well, I have to plug it into both of those inequalities. Let's do that really quickly. I need a quiet raised hand. Help me plug in 2, 1 into the first inequality. Kira, go for it.
2 minus 4 times 1 is greater than -5.
It's greater than -5. Perfect. Thank you. Another volunteer, reduce. I now have substituted 2 and 1 in. Emma? Yep. So that's 4. 2 minus 4 is...
Oh, 2 minus 4 is 2.
Careful. Which one is bigger, the -4 or the 2?
I mean the 2s. So yeah.
So 4 is the bigger number, and that one was negative, which means our answer should be... Oh, careful. No, so you had the number right. I was just... There's the sign out here. That was the error.
Oh, the
-2, exactly. Because the 4 was the bigger number, and that was negative. Perfect. So -2, continue on, is... Just...
oh, is greater than -5.
Is that true or not? And that's a class question, not just an Emma question. Is -2 greater than -5? I need thumbs on this one. Can you guys give me a thumbs up if you think it's true and thumbs down if you think it's false? Because it looks like 5 is bigger than 2, right? So, the answer is actually thumbs up. Because if I think about this in terms of a number line, my number line, I have 0 here, -1, -2, -3, -4, -5. Which one is more to the right? -2 or -5? Well, -2 is farther on the right. So -2 is indeed bigger than -5. So we can do a capital T for true or a check mark, whatever you want to say. There's no official rule for this one. But okay, that one worked. Now we have to check the second one. If it works for both of them, then it's a solution. If it doesn't work for both of them, it's not a solution. All right, so another quiet raised hand. How do I plug in the 0.21 into our new inequality? Larissa.
You would do 5 times 1 in parentheses is less than or greater to 6 minus 2.
6 minus 2. And yeah, it should be less than or equal to, but I think you got it. Another quiet raised hand. Can you please simplify it into just some simple, yeah, Ulysses.
It'd be 5 less than or equal to
4. Is that true or not true, Ulysses?
no.
No, okay, so you can put a false or you can put like an X or whatever you want to do. Okay, they both had to be true. This is a false statement. So our answer down here is no. The end. And if you want to be more specific in your example, you can say no because it didn't satisfy both of the inequalities. I don't want to write that all out. I think you guys clearly see that from up above. All right, so the final type of question that I can ask you is a graphical question, not an algebraic question. Let's graph -2, 1. Everyone do it now. On this graph, graph -2, 1. -2, 1. I'll put the answer up in 5 seconds so you can check your work. I want to make sure that you at least try the problem. -2, 1 is right there. Everyone's got it okay? Give me thumbs up, thumbs down. Did you get that point? We're all good at graphing? All right, so it's in the shaded region, but it should be in the double shaded region because double shaded region should satisfy both of the inequalities. This only satisfies the red inequality, not the blue inequality. It has to be somewhere in this triangular region up here in order to satisfy both of the inequalities. So the answer here is no. No, it has to be in that double shaded region. Let's try kind of similar, not -2, 1, but +2, 1 now. Everyone graph +2, 1. So +2, 1, I'll do that in yellow, is right. Oh, that's kind of hard to see. Let's do it in black. +2, 1. Ooh, that's on the line. Is that technically in the triangular region or not? Give me thumbs up or thumbs down. Do you think it's in that region or not? Interesting, interesting. Kira, you are giving me thumbs down. Why is it thumbs down?
Because it's not in the shaded region. It's like it's neither above nor below.
Okay. Can you call on someone to represent the other side of the battle, I guess?
Well, I think it is because it's on a solid line. Not a, like it's on a solid line, so it could be. It should be a solution.
Okay. And then what? You still have your hand up?
Yeah. And to back up Ash's answer, if it's on a solid line, the solid line is saying that it's like greater than or equal to or less than or equal to. So if it's saying or equal to, then it has to be also equal to the shaded triangle area if it's on a solid line.
Exactly. Yeah. So the answer is actually yes. It is a solution because it is in. I mean, it's not technically inside of the region, but it is a solution because anything that's on the red line or above it, or I guess to the left of it in this case, anything. Oh, it actually is to the left. So you do need to use above and below as much as possible. So it is above the red line and on the red line. So technically that point is a solution to the red line, and it's definitely a solution to the blue line because it's definitely above this blue line as well. So the answer here is yes. Cool, and that concludes the notes. I need you guys to give me a fist of 5 on our objective for today. Determine if a point is a solution algebraically and graphically. How well can you do example 4 and 5 on your own? I see a 10 and a 5, a 5, a 5, a 5, a 4, a 5, a 5, a 4. Ulysses, what'd you give? And a 5. Okay. Perfect. Thank you, guys. You can start on Khan Academy homework. Please start within that minute window. Thank you.